So you've got these great ideas, right? Maybe notes for a project or even like a business idea brewing. But then you hit that wall. How do you actually get it online? How do you go from just, using the internet to publishing something for everyone? It can feel a bit like trying to learn a secret language sometimes. Well, let's try and unpack that today. On the deep dive, our mission is really to cut through all that complexity. We want to give you a shortcut, basically, to understanding those fundamental building blocks of web publishing. Demystify it all, from the basic structure right up to getting your site seen. Our insights today, they're distilled from the HTML, CSS, and JavaScript web publishing in 1 hour a day resource, which is frankly a great guide. It's really designed to take you from just being a curious web user to someone who feels confident publishing online. So what can you expect from this deep dive? Well, we're going to zero in on the core languages, things like HTML and CSS. We'll walk you through setting up your digital workspace, and then review how modern web design really has to think about everything from mobile users, which is huge now, to search engines. Think of this as getting that essential foundation you need, quickly, thoroughly, so you can actually bring those ideas to life online. The world of web publishing, more than just browsing. Okay, let's start right at the beginning then. What is web publishing? Really, for most of us, our relationship with the internet is just as a user, right? We open Chrome or whatever, click links, read stuff, watch videos, consume. But web publishing flips that script. It's moving from consuming to, well, creating, putting your information, your ideas out there. And it's surprisingly powerful when you think about it.
Yeah, and what's fascinating is the core idea, hypertext, linking documents together that wasn't even new with the World Wide Web. There were systems like HyperCard before it, but the web took that concept and just exploded it globally, made it universal. Suddenly you could link anything to anything, anywhere.
Yeah.
That was the real game changer.
And the advantages are just huge, aren't they? Unlike, say, printing a book, web content can be updated constantly at basically no material cost, no need for a whole new print run. You can keep info current, fix mistakes instantly, reach people right away.
Which leads to this strong ideal in web development, the cross-platform ideal, this belief that the web should just work on any device, any OS, any screen size.
A noble goal.
Absolutely. But reality threw in some curveballs, things like Flash, which the source mentions was non-standard proprietary tech, and then the absolute explosion of mobile devices. It really challenged that purist view. So now developers are always making this choice. Do I build a native app, for iPhone or Android, maybe get some specific device features, or do I stick to web standards? Aim for that universal reach. It's like a constant balancing act.
Right. And to make any of this happen, you absolutely need two key things. First, a web browser like Google Chrome, which funnily enough is what they used for the screenshots in our source material. And second, you need a web server, that's the program, often running somewhere else entirely, that actually delivers the web pages, handles forms, talks to databases.
It's the engine room, really, the invisible backbone. And the thing that connects it all, the address system, is the URL Uniform Resource Locator. And it's important to get this. A URL isn't just for web pages. It's a pointer to any data online, an image, a CSS file, a script, anything. And defining the rules of the road, the languages like HTTP and HTML, that's the job of the W3 Consortium, the World Wide Web Consortium. They're the ones trying to set the standards, keep things working together. Without them, it'd be chaos.
Okay, so just a quick check-in then. Based on that, what's the absolute fundamental thing you need to actually publish documents on the web?
Yeah, it really just boils down to one thing.
Yeah.
You need access to a web server. That's your platform. That's your stage. 2, getting your tools in order, your digital workbench.
All right, we know the what's. Let's talk how.
Yeah.
Getting your tools sorted out, like setting up your digital workbench. The simplest way to start. Jump into one of those online content management systems, a CMS, things like Tumblr, Wix, Squarespace, Weebly. You've probably heard of them.
Oh, yeah, they're everywhere.
They give you templates, help with domain names, e-commerce, multimedia. They make it super easy to just publish content right away. No code needed, usually.
They are fantastic for getting started fast. Absolutely.
Yeah.
But, and this is a big, but understanding the underlying structure, basically, HTML is still so important. Think of it like a CMS gives you a nice prefab house. Looks great.
Right.
But if a pipe bursts or you want to add a really unique extension, you need to know something about the actual structure, the plumbing. Without knowing HTML, you'll hit a wall with troubleshooting or doing anything beyond what the template allows. It gives you the real control.
That makes sense. So if you do want to build from scratch, what are the bare essentials? Surprisingly simple, actually. Just a text editor and a web browser. And when we say text editor, we mean plain text, ASCII. Not Microsoft Word or something that adds hidden format.
Yeah, that'll break your code fast.
Exactly. Think Notepad on Windows, TextEdit on Mac if you set it to plain text mode, or Vi, Emacs on Linux. There are more powerful code editors too, like Komodo Edit mentioned in the source. And for your browser while developing, Google Chrome's developable tools are indispensable. Quick shortcut. Control plus Shift plus I on Windows, Command plus Option plus I on a Mac, pops them right open.
And inside those tools, that little inspect button, magnifying glass, that's your magic wand. Lets you point at anything on any web page and see the HTML and CSS behind it.
Like X-ray specs for the web.
Totally. It's amazing for learning how things are built and absolutely essential for figuring out why your own stuff isn't working right. Debugging becomes so much easier.
Okay, tools ready. Now, planning your content. Content is just the general term, right? Text, pictures, videos, forms, basically what your site is about. And really, your imagination is the only limit here. The best sites are the ones that do something new, something interesting. But before you just start throwing content onto pages, especially for bigger sites, or if you're working with others, wireframing is a critical step. It's not about making it look pretty yet. It's a rough outline. Which content goes where? How do pages connect?
Like a blueprint for a house.
Exactly. It stops you getting lost later when things get complex, ensures everything has a logical place.
And wireframing forces you to make key decisions early on, like how much info goes on one page. Some sites are just one long scrolling page now. Others are split into many tiny ones. And how will content load? Does the whole page refresh every time, or do parts update dynamically? That affects speed and how users feel using the site.
And finally, to get it all online, visible to everyone, you need that web hosting account.
Yeah.
Simplest way. Upload your HTML, images, CSS to a server that's connected to the web. And those CMS platforms we talked about, Wix, Squarespace, they usually handle this for you. They bundle the hosting in.
Yeah, they abstract away that server management part, which can be complex. They give you the space and make it easy to put your files there. 3, the core languages, HTML and CSS.
Okay, let's really dive into the core languages now. The absolute foundation, HTML and CSS. Think of HTML hypertext markup language as the skeleton. It provides the structure. Its job is to describe your content. This is a title, this is a paragraph, this is a list. It's not about visual.
Not at all. That comes later.
And remember, HTML files are just plain text, ASCII. Any basic text editor will do the job. The basic anatomy of an HTML tag is usually tag name some content tag name, an opening tag, the content, and a closing tag with a slash. And a little quirk, HTML tags, they're not case sensitive, so P is the same as P, though lowercase is standard practice now.
Right, keeps things consistent.
And one thing that makes life easier for developers is how HTML handles white space. Extra spaces, tabs, line breaks in your code. The browser mostly ignores them when displaying the page.
With a few exceptions, yeah, like the pre-tag.
Which means you can indent your code, add blank lines, make it super readable for yourself, and it won't mess up the final look. It's great for organization. Now, tags can also have attributes, little bits of extra info inside the opening tag. There are global attributes that work on almost any tag. 2 really important ones are id and class.
Crucial for CSS and JavaScript.
Exactly. id gives a unique name to one specific element on the page, like its personal ID number. Class, on the other hand, assigns a category or label. You can give the same class to multiple elements.
Like grouping things together?
Yeah, so you can style all elements with that class at once using CSS. Now let's talk HTML5, that simplified DOC type P HTML right at the top. That's the signal you're using HTML5. It's super well supported now, has lots of new features. It's really the standard you should be using.
And that shift to HTML5 was significant. Older XHTML was really strict. Everything lowercase, those self-closing tags like im and g attributes, always needed quotes.
A bit fussy.
Yeah, a bit. HTML5 is much more flexible, more forgiving, while still being powerful semantically. It just makes writing code easier, less error-prone.
So when you start any HTML page, you basically always have these 3 core tags setting up the structure. HTML wraps everything and says, this is HTML. Then head, this holds background info like the page title, but not the content you actually see.
Right. That's a common confusion. The head is for meta info, links to style sheets, scripts.
Exactly. All the visible stuff, the text, images, everything the user sees goes inside the body tags. And that page title, defined by title inside head, that's what shows up in the browser tab. Super important for users navigating tabs, and also really important for search engines. For structuring your actual content, you've got headings, H1 down to H6.
6 levels. H1 is the most important, like the main page title.
And then for regular text, you use paragraphs, the P tag. Good practice is to always use the closing P, even though browsers are sometimes forgiving. Keeps it clean.
Definitely. Explicit is better than implicit.
And if you need to leave notes for yourself or others in the code, Comments, your note here, browsers completely ignore them. V, organizing information with lists. Okay, moving on. Lists in HTML. They are incredibly useful for organizing information. Very powerful. You get 3 main types. First, ordered lists. OL, these are numbered lists. 1, 2, 3.
Pretty self-explanatory.
Yeah, and you can actually change the numbering style with CSS. Like use Roman numerals or letters instead of numbers. The list style type property handles that. Then you have unordered lists. OL, these are bullet points by default. And again, CSS lets you change the bullet style, squares, circles, no bullets at all.
Or even use your own image as a bullet with list style image. That can be a nice touch.
Definitely. And the individual items in both ordered and unordered lists, they're marked up with the line tag, list item. Now, the really cool part is you can nest lists, put lists inside other lists.
As deep as you need to go.
Exactly. For complex outlines or hierarchies. And indenting your HTML code here really helps you see that structure.
Yeah, makes it much easier to read.
And here's a key insight. Lists aren't just for making, well, lists of things like you'd see in a document.
No, absolutely not. They're fundamental building blocks for so much more on the modern web. Think about website navigation menus, those drop-downs, the main site navigation bar. Very often under the hood, those are just Olamic elements. Unordered lists, styled heavily with CSS to look like menus. They're also used for displaying sortable data, feeds of items. They provide a clean semantic structure that CSS can then transform into almost anything, way beyond simple bullet points, connecting your content, working with links.
All right, the heart of the web, connecting content, links. Hyperlinks. This magic happens with a tag, the anchor tag, and the key attribute is href. That's where you put the destination URL, telling the browser where to go when the link is clicked.
The hypertext reference.
Exactly. Now, linking pages within your own site is super common. You'll often use relative path names. These describe the location of the linked file relative to the current page.
I'd like go up one directory, then into the images folder.
Right. And this is crucial for portability. If you use relative paths, you can move your whole website folder somewhere else, maybe to a different server, and the links won't break.
Super important. Remember forward slashes like on Unix, Linux, and autonomies go up one level.
There are also absolute path names, which start right from the root directory of the site, always beginning with a dot. Less common for internal links, usually. You can also link within the same page. Great for long pages.
Yeah.
You give an element an id, like id summary, and then you link to it with hashtag summary in the href.
Hashtag summary jump to Samaria. Perfect for tables of contents or skipping sections.
Yeah, it makes long pages much more navigable. And just to break down a URL, you've got the protocol, HTTP, FTP, the server name, www.example.com, and the path to the file or resource. But URLs aren't limited to just HTTP. You can link to FTP files with FTP or even use Mailto to automatically open the user's email client pre-filled.
Yeah, you could even add the subject and body with .subject, high and body. Just wanted to say. Pretty handy sometimes.
Definitely.
And a quick pro tip, often overlooked. Always try to include the trailing slash on URLs that point to directories like www.example.com/products. It seems small, but it can actually help the server find the directory's default page, like index.html, a tiny bit faster, avoiding an unnecessary redirect step. Every little bit helps performance.
7, formatting text with HTML and CSS.
Okay, let's talk formatting text. We know CSS does the heavy lifting for visuals, but HTML does have tags for giving text semantic meaning. Beyond just a P for paragraphs, you've got M for emphasis, usually shown as italics, and for strong emphasis, usually bold. The key is they convey meaning, not just style. Right. It tells assistive technologies why the text is different. It's semantically important, not just visually styled.
Then there are tags like code, samp, d, var for specific things like code, sample output, keyboard input, variables. These usually get affixed with font by default, helping them stand out.
And cite for citations or titles of works, often italicized.
But for really precise control over how text looks, that's all CSS font properties. Font size, font weight for boldness, font style, italics, text decoration, underline, line through. You get fine-grained control there.
Little control over typography.
What if you need to preserve white space exactly, like for code examples or ASCII art?
That's the pre-tag. Pre-formatted text. It respects all your spaces, tabs, line breaks.
But remember, you can't really put other HTML tags inside pre. It's quite literal. And for a simple horizontal line, the HR tag, horizontal roll.
Though nowadays, you'd almost always style that line using CSS. The old HTML attributes for it are obsolete in HTML5. CSS gives you way more control over its look.
Good point. Now, really practical things. Special characters. How do you type things like A or A? You use character entities. Special codes starting with anid and ending with in.
Like in copy for the copyright symbol, or Anycute for the accented E. Or you can use their numeric codes like ANTAG 169.
These ensure they display correctly everywhere.
Absolutely essential. And this ties directly into character encoding. For any modern web page, you absolutely should declare UTF-8 encoding. Put metachar set UTF-8 inside your head. UTF-8 handles basically any character from any language, plus emojis. It's the universal standard now, avoids all sorts of display problems. 8. Using CSS to style a site. The power of design.
So how do we actually apply these CSS styles? There are three main ways. First, inline styles. You put a style attribute directly into the HTML tag, like pStyleColor.blue.
Quick and dirty, but not very flexible. It mixes your structure and presentation.
Right. Hard to manage on bigger sites. Second, page-level styles. You put CSS rules inside a style tag, right in the HTML document's head.
Okay, for styles unique to just that one page.
But the best way, the standard practice, is using external style sheets. A separate file, usually ending in .css, that you link to from your HTML using the link tag in the head.
Yes, this is the way to go. It separates your concerns, HTML for structure, CSS for presentation. You can control the look of your entire site from one CSS file. Change a color once, it updates everywhere.
That's powerful.
It promotes reuse, makes maintenance way easier, and browsers can cache that single CSS file, making your site load faster for repeat visitors. It's much more efficient.
Okay, so how does CSS know which elements to style? That's selectors. The simplest is an element selector. Just use the tag name like h1color.green, styles all h1 tags.
Straightforward.
Then class selectors, you add a class attribute in your HTML like class important. In CSS, you target it with a dot important, font weight, bold.
Yeah, styles everything with that class.
And you can combine them, right?
Yeah.
Like p important. Exactly. Only paragraphs with the class important. Very useful. And for targeting one specific element, that's the ID selector, use the ID attribute in HTML, like Eden main logo, and target it in CSS with a hash. Hashtag main logo.
IDs must be unique on the page. Only one element can have a specific ID.
Crucial point. And another common mistake, when you write Eden main logo in HTML, don't put the hash there. The hash is only for the CSS selector.
Yeah, Eden main logo, but hashtag main logo in the CSS.
Got it. Now, units of measure in CSS, super important, especially for making sites responsive. You've got absolute units like px for pixels, fixed size, but relative units are often better for flexibility. ED is relative to the parent element's font size. Rem is relative to the root element's HTML font size, often preferred now for consistency.
And VH and VW, viewport height and width. Great for scaling things based on the screen size itself.
Absolutely key for mobile. And colors, lots of ways. Hexadecimal, hashtag FS000, RGB, RGB25500, HSL, even name colors like red. Hex is probably still the most common you'll see.
Quick tip. Always validate your CSS. Use the W3C CSS validator jigsaw.w3.org CSS validator. It catches typos, errors, ensures your CSS is standard compliant. Save a lot of headaches debugging weird layout issues. Just paste your code or URL in.
Okay, let's unpack the box model. This is fundamental to how CSS layout works. Every single HTML element is treated like a rectangular box. Imagine a box. Inside, you have the content and the text, image, whatever. Around the content is padding, space between the content and the box's edge.
Pushes the border away from the content.
Then you have the border itself, the visible line around the box. And outside the border is the margin, space between this box and other boxes around it.
Content, padding, border, margin, from inside out.
And you control each layer with CSS padding, border, which has style, width, color properties, margin. Understanding this lets you control spacing precisely.
And a little nuance. The background color you set on the body tag, it actually fills the whole viewport, including its margin area, which is slightly different from other elements. Just something to be aware of.
Good point. We also need to control how elements behave block versus inline. Block elements like pdiv take up the full width available, start on a new line. Inline elements like a span M only take up as much width as their content, flow within the text.
And CSS display property lets you change that default behavior. You can make an inline element act like a block and vice versa. Very powerful.
And sizing width, height plus max width, min width, etc. for more flexible control. What happens if content overflows its box? The overflow property handles that. Visible, hidden, scroll, auto.
Auto is often useful. Add scroll bars only if necessary.
And finally, pseudo classes add dynamic styling.
And before after, let you generate content with CSS, like adding icons or decorations without extra HTML. Super handy. IX, using images on your web pages.
All right, let's make things more visual. Images. What formats work on the web? You've got GIF, good for sharp lines, simple animations, but only 256 colors. JPEG or JPG. Millions of colors, great for photos. But it's lossy compression, smaller files, but some quality loss.
You control the compression level, finding a balance.
And PNG. Often replaces diff, more colors, supports transparency, alpha channel, and it's lossless, no quality loss, but files can be bigger than JPEGs. And the newer kid on the block for HTML5 is SVG Scalable Vector Graphics.
These are amazing. They're XML-based, basically code-defining shapes and paths. They scale infinitely without getting pixelated. Perfect for logos, icons, illustrations that need to look sharp at any size.
You create them in vector software like Illustrator. Now, the main tag for putting an image on a page is MMG. In HTML5, it absolutely requires two attributes, src, the image file URL, and alt, alternative text.
Don't skip the alt text.
Seriously, don't. It's crucial for accessibility. Screen readers read it aloud for visually impaired users, and it's vital for SEO. Google can't see images, so alt text tells it what the image is about. Huge impact.
If the image is purely decorative, use alt, empty alt, but never just omit the attribute.
Good distinction. How do images interact with text? By default, they're inline. The vertical align CSS property controls how they line up with the text baseline. But if you want text to wrap around an image, use float.left or float.right in CSS.
It makes the image float to the side and text flows around it. Classic layout technique.
And to stop the wrapping below a floated image, use clear both or left-right on the element you want below it.
Pushes it down past the floated element.
Want to make an image clickable? Just wrap the img tag inside an ANA tag.
Simple as that. But remember to use CSS to remove the default border browsers. Add to linked images, border, not none. Looks cleaner.
Right. And sizing images. Best practice is CSS width and height. You can also use background image in CSS to put images behind any element, control tiling, position, very flexible for design. And lastly, image maps. Clickable regions on a single image. You use map and area tags in HTML to define the shapes, rect, circle, poly, and their coordinates. Then link the image to the map using useMap, #mapname.
But again, accessibility is key here. Always provide alternative text links for image map regions so non-visual users can still navigate. Don't rely solely on the visual map. X, building tables, structured data.
Okay, next up, tables. Let's be really clear here. Tables are for tabular data, like spreadsheets, rows, and columns of related information.
Not for laying out your entire page. That's what CSS is for. Using tables for layout is a big no-no these days. Bad for accessibility, bad for maintenance.
Absolutely. So the basic tags, table wraps the whole thing. Table defines a table row. Eighth defines a table header cell, usually bold, centered, indicates what the row or column is about. And table defines a regular table data cell.
Simple structure. Table contains rows, rows contain cells, either header or data.
How about spacing? CSS controls this. Padding for space inside the cells, between content and border. Border spacing for space between the cells themselves.
And border collapse lets you choose if cells have separate borders or if they merge into single lines. Collapse is common.
Sizing columns, CSS width. Aligning text in cells. Text align, horizontal and vertical align. What if a cell needs to span multiple rows or columns?
Use the row span attribute on Zort or TD to span vertically across rows. And colspan to span horizontally across columns, lets you create more complex table structures.
And HTML5 added semantic sections, head for the header rows, T-body for the main data rows, and T-foot for footer rows.
Love structure complex tables, especially for accessibility and styling hooks. Good practice to use them. HUA, using CSS to position elements on the page.
Let's circle back to CSS layout and positioning in a bit more detail. Moving those boxes around, we talked about the box model. How do we actually position things? The position property is key. Default is static, just follows the normal flow of the page. Relative lets you shift an element from its normal position, but importantly, it still occupies its original space in the flow.
Other elements still behave as if it were in its original spot.
Right, then absolute. This positions an element relative to its nearest positioned ancestor. An ancestor that isn't static. Yeah. And crucially, absolute elements are removed from the normal flow. Other elements act like they aren't there.
They could overlap other content easily.
Exactly. And fixed is similar, but positions relative to the browser window, the viewport. It stays put when you scroll.
Also removed from the flow. Great for navigation bars or banners that need to stay visible.
And when things overlap, Z-index controls stacking order. Higher numbers go on top.
Only works on positioned elements, not static.
Good point. Another layout technique is floating, using float. Left or float, right? This also takes the element out of the normal flow and lets other content wrap around it.
Like text wrapping around an image in a magazine.
But you often need to use the clear property on elements after the float to stop them wrapping and force them below it.
Yeah, clear. Both is common to end a floated section.
And a reminder on organizing your CSS. Use external files. Use meaningful class and ID names. Main nav, error message, not blue text or big box.
Makes your code understandable and maintainable, especially as the site grows or the design changes. Future you will thank you. 12. Designing forms. Interacting with users.
Okay, let's talk forms. This is how you get input from your users. Searches, contact forms, login, checkout. The data usually gets sent to a server-side script for processing. The main container is the form tag. 2 key attributes. Action, the URL of the script that handles the data. And method, either post or get.
Post sends data invisibly in the request body. Uses when the action changes something on the server, like submitting an order, posting a comment. Get appends the data to the URL, making it visible. Good for searches or things that don't change data. Use post for sensitive info or actions that modify data.
Right. Inside the form, you have controls. The input tag is incredibly versatile. Its type attribute changes everything.
Right.
Type text for single-line text box, type password for masked input. But remember, this is not encryption, just a visual mask.
Need HTTPS for real security there.
Definitely. Type submit for the submit button. Type reset to clear the form. Type checkbox allows multiple selections. Type radio allows only one choice from a group. They need the same name attribute.
Type hidden sends data programmatically, invisible to the user. Type file lets users upload files.
And HTML5 added loads more useful types. Email, date, number, color, range, a slider. These often bring up specialized keyboards on mobile and have built-in basic validation.
Very helpful for user experience.
And for accessibility, the label tag is critical. Use the attribute to link it to the id of the input field.
Makes the label clickable too, which is great, especially on touchscreens. You can also nest the input inside the label.
For multi-line text, use text area, drop-down menus or lists, select with option tags inside. To group related controls visually, field set wraps them, and Legend provides a caption for the group.
Like grouping shipping address fields together. Improves clarity.
And Tab Index lets you control the tabbing order through the form fields for keyboard users. HTML5 also added progress for showing task completion, like a progress bar, and meter for displaying a value within a known range, like disk usage.
And don't forget, while these have default looks, CSS can style all of these form elements extensively. You can make them match your site's design perfectly, making them look custom and integrated, not just like generic browser controls. 13. Structuring a page with HTML5. Semantic power.
Let's talk about structuring a whole page in the modern era using HTML5. We have to remember the dark ages, using HTML tables for page layout.
Oh, the pain. Nested tables, spacer GIFs, Shutter.
Terrible for accessibility, slow, impossible to maintain. CSS came along to fix that, separating layout from structure. And HTML5 took it further with semantic elements. These are tags that have meaning, replacing generic div tags in many cases. We have header, not just the document head, but the header section of a page or article, nav, specifically for navigation links. Section for a thematic grouping of content. Article for self-contained content, like a blog post you could syndicate.
Yeah, something that makes sense on its own.
Aside for related but separate content, like a sidebar. And footer for the footer of a page or section.
These tags aren't just about looks. They create a meaningful document outline. Browsers, screen readers, search engines can understand the purpose of different parts of your page much better.
So while div is still useful for generic containers needed for styling.
Right, it's not gone. But you should use the semantic tags whenever they fit the meaning of the content. It drastically improves accessibility, makes your code easier to understand and maintain, and it's definitely good for SEO. Search engines love structure they can understand. Parfait. Integrating multimedia, video and sound.
Okay, let's add some action. Multimedia. Video and sound. For video, you can host it externally. Sites like YouTube, Vimeo.
They handle the storage, the bandwidth, the different formats. It's often the easiest option, especially for high traffic.
The downside is less control, maybe ads you don't want.
It's exactly. Convenience versus control. If you self-host, you need to think about encoding. H.264 MP4 is the most widely supported codec. WebM is a good open-source alternative using VP8 or VP9 video. Ideally, offer both formats to cover all modern browsers. Tools like Handbrake are great for optimizing video files for the web, compressing them effectively.
And HTML5 gives us the video tag for native embedding. Attributes like SRC, the video file, controls, shows player controls, autoplay, use carefully, loop, muted, poster, and image shown before loading.
And critically, the source tag inside video. This lets you list multiple video files in different formats. Source src movie.mp4 type videom4, source src movie.web type video web. The browser picks the first one it supports. Essential for compatibility.
Anything between the opening and closing video tags acts as fallback content.
Right. If the browser doesn't support HTML5 video at all, it shows that content may be a message, or a Flash player using Object for really old browsers, or just a download link.
And there are also JavaScript video players, Flow Player, JW Player, that provide custom interfaces and features, often built on top of the native video tag.
They can smooth out browser inconsistency.
Audio is very similar, using the audio tag. Same idea. SRC, controls, autoplay, loop, muted. And use source tags for different audio formats like MP3, OGG Vorbis, AAC.
I'll say it again. Never autoplay or preload media unless the user explicitly expects or requests it, especially on mobile. Respect bandwidth and avoid annoying your users. Axb ZTime. Advanced CSS, page layout, and CSS.
Let's revisit CSS page layout. Why is better than those old tables? Easier maintenance. Change one CSS rule, the whole layout can shift. No digging through nested table cells.
Better accessibility. Screen readers understand CSS layouts much better than tables used for visual formatting.
Smaller files. Faster loading. Cleaner code is generally smaller and faster, so in planning layout, you need a strategy. Fixed layout, specific with liquid layout. Adapts to the window.
You need to decide based on your content and audience. How many columns? Does it need to be fluid or pixel perfect? Thinking this through up front saves time later.
We talked about position. Static, relative, absolute, fixed, and z-index.
Controlling exactly where elements sit, how they overlap.
And float, left or right, with clear to manage the wrapping.
These are the traditional workhorses of CSS layout, though newer techniques like Flexbox and Grid are often preferred now for complex layouts. Understanding position and float is still fundamental.
And remember to organize your CSS well in external files with descriptive names using responsive web design, RWD. Okay, a huge topic. Responsive web design, RWD. Absolutely essential today. The core idea. Mobile first. Design for the smallest screen first, then add complexity for larger screens.
This is key. It forces you to prioritize content and performance from the start. Old way was designing for desktop, then painfully trying to shrink it, which rarely worked well. Mobile traffic is massive now, and Google prioritizes mobile-friendly sites. So mobile first isn't just nice, it's necessary.
And RWD is more than just columns resizing. It's adapting everything. Prioritizing content differently on small screens, maybe hiding less important things, providing alternatives for features that don't work well on touch.
And considering bandwidth, mobile users might be on slower connections or have data caps. Optimize fiercely.
The technical core of RWD is media queries. The @media rule in CSS, @media minwidth, 768px. Apply these styles only if the screen is at least 768 pixels wide.
You define breakpoints widths where your design needs to change to look good. Each breakpoint adds another layout variation.
Responsive images and video are tricky. Fixed size is bad. Flexible width 100% works, but can be slow or blurry if the image is too small or too large.
The best but most complex approach is often serving different sized images based on screen size and resolution. More work, but best user experience. Technologies like the picture element or Sarset attribute help here.
RWD best practices recap. Text first. Optimize images, keep video small, compress everything. Limit external resources like fonts.
Basically make it fast, lean, and focused, especially for that initial mobile view. And the great secret, this makes the site better for everyone, even desktop users. Faster load times, clearer content, it's just good design. X7, introducing JavaScript.
Let's talk interaction. JavaScript. This is the programming language that makes web pages dynamic. It lets you change content after the page loads, respond to user actions, create animations, fetch data, all without reloading the whole page.
It turns static documents into interactive applications.
You include JavaScript using the script tag. Best practice for performance. Put script tags right before the closing body tag.
Because script loading and execution can block the browser from rendering the rest of the page. Putting it at the end lets the visible content load first.
You can also link to external JS files using the src attribute, which is great for reusing code. JavaScript basics, it's case-sensitive var or newer letconst, declares variables. Standard operators for math and comparisons. If-else for decisions, for, while loops for repetition, watch out for infinite loops.
And functions. Reuse the block bar, absolutely fundamental.
And how does JavaScript interact with the page?
Through built-in objects. The window object represents the browser window itself. The document object represents the HTML page loaded inside it. These objects have properties and methods you can use to access and manipulate everything. The HTML structure, the DOM, the CSS styles, browser features, that's the bridge. 8.8, using jQuery. Simplifying JavaScript.
Now, writing raw JavaScript, especially dealing with differences between browsers, can be tricky. That's where libraries come in. jQuery was, and in many places still is, incredibly popular. It's a JavaScript library.
Its motto was, write less, do more. And it really delivered on that for a long time.
Why use it? It smoothed out browser inconsistencies. It provided simpler ways to do common tasks, selecting elements, manipulating them, animations, AJX.
Made things much quicker, especially complex DOM manipulation.
You include it by linking to the jQuery.js file, often from a CDN for speed. The core idea is the function. You use it with CSS-like selectors to grab elements. Teori gets all paragraphs, #myID, gets the element with id, myID.
Very intuitive if you know CSS selectors.
Then you chain methods onto it to do things to the selected elements. A key pattern is document.ready function, or the shorthand function.
This ensures your code only runs after the whole HTML document is loaded and ready, preventing errors trying to manipulate elements that don't exist yet. Crucial.
jQuery makes DOM manipulation easy. Terapply founders for attributes, CSS for styles, add class, reform values, append remove for adding moving elements.
And it had nice built-in effects, hide, show, fade in, slide down, easy animations.
And it made AJX much simpler.
AJX, Asynchronous JavaScript XML, lets you fetch data from the server without a full-page reload.
Think auto-suggest in search boxes, loading new content when you scroll.
jQuery's load, post methods made these background requests much easier to write than using the raw underlying JavaScript objects. It abstracted away a lot of complexity. Using JavaScript in your pages. Practical applications.
Okay, let's see. JavaScript or jQuery in action. Practical uses. Client-side form validation. Checking user input in the browser before they even submit.
Why? Saves a round trip to the server just to find out you missed a required field. Gives instant feedback. Better UX.
Right. You typically attach your validation code to the form's onSubmit event. Instead of annoying alert boxes, better to display errors next to the fields, maybe add a red border using CSS.
And use event.preventDefault in your JavaScript to stop the form from actually submitting if there are errors.
Another great use, hiding and showing content using progressive enhancement. The principle, build the page so it works without JavaScript first. All content should be accessible.
Then, use JavaScript to enhance it. Hide answers in an FAQ, show them on click. Make an image carousel interactive.
This ensures that if JS fails or is disabled, the user still gets the core content. Super important for accessibility and robustness.
For example, in FAQ, HTML has questions and answers visible. JS runs, hides answers, adds click events to questions to reveal them. If JS is off, you just see questions and answers. Perfect fallback.
JavaScript also lets you dynamically add or remove elements from the DOM.
Document.createElement, append child, remove child. This is how you build things like infinite scroll, adding items to a list without reload.
Finally, debugging. You will have bugs. Learn to use your browser's developer tools.
The console for error messages, the sources tab to set breakpoints, step through code, inspect variables. Absolutely essential skill, working with frames and linked windows.
Let's touch on frames and linked windows. First, a big HTML5 change. Frameset is obsolete.
Yeah, those old school pages split into multiple independent HTML documents in one window. Gone, thank goodness. They were terrible for usability and SEO.
But inline frames using the iframe tag are still very much alive and supported. They let you embed a whole separate HTML document inside your current page, like embedding a YouTube video or a Google map.
Uses SRC for the embedded page's URL plus height, width, etc.
And a crucial security feature, the sandbox attribute for iframe. This restricts what the embedded content can do, block scripts, prevent pop-ups, stop it accessing the parent page. Vital if you're embedding untrusted third-party content.
Use it. Don't embed external content without sandboxing unless you absolutely trust it.
Now, controlling where links open, the target attribute on a tag's, target blank, opens in a new tab or window, very common. Target self opens in the same frame window, the default. Parent and top are for breaking out of frame sets. Less relevant now, frame set is gone, but still exists.
And you can give a frame or iframe a name attribute and then target that specific name. Target my frame name.
The base target, tag in the head, can set a default target for all links on the page. And you can also open windows programmatically with JavaScript using window.open.
Gives you control over the new window size, features, toolbars, scroll bars. But browsers often block pop-ups open without direct user interaction.
So the unobtrusive approach is best. Attach window.open to a links click event in JS and use event.prevent default to stop the normal link click. Keeps HTML clean, works better with pop-up blockers. XD2, designing for user experience, UX. Okay, bringing it all together now, let's talk user experience. UX, it's all about how users feel interacting with your site. Can they find what they need easily? Is it pleasant to use? Can they achieve their goals?
It starts with defining those goals. What do you want people to do? Buy something, learn something, sign up.
Then tailor everything, content, design, navigation to your target audience. Who are they? What do they need? An academic site needs different UX than a gaming site.
Absolutely. And think about guessable URLs. Use clear, logical directory names, products, about, blog, makes the site structure intuitive.
And a massive part of UX is accessibility, designing so people with disabilities can use your site effectively.
Visual, auditory, motor, cognitive disabilities. Web accessibility aims to include everyone.
And let's bust a myth. Accessible design does not mean boring or ugly.
Not at all. It just means using clean, standard HTML and CSS correctly, good structure, semantic markup.
Key practices. Use descriptive link text, not click here. Provide meaningful alt text for images. Use captions transcripts for multimedia, track tag. Ensure logical tab index for forms so keyboard navigation works.
And consider content order in HTML for screen readers. Maybe nav comes after main content in the source, then CSS positions it visually at the top, plus a skip to content link.
The great thing is many of these practices overlap with mobile-first design. Making things clear and simple benefits all users. EXIC-I, designing for the mobile web. Beyond responsiveness. Which leads us back to designing for the mobile web, beyond just RWD. Again, progressive enhancement is key. Build the basic functional site first, then layer on the bells and whistles with CSS and JS for capable devices.
Core content and functionality must work even if JS is off, always.
Validate your code. HTML, CSS, JS. Use the W3C validators, validator.w3.org. Clean code works better everywhere. Writing for mobile. Be concise. Short sentences. Break text up. Important stuff first.
Mobile users often scan quickly, have less patience, get to the point, avoid jargon like click here, use select this link, or similar.
Keep design consistent. Make links large enough to tap easily. Optimize images aggressively. No auto-playing media. Avoid Flash.
Put CSS, JS, and external files for caching. Use CDNs for libraries. Keep things fast.
And leverage mobile features. Geolocation, with permission, for location-aware services. Click to call SMS links for phone numbers.
Ahrefs-Tel plus 15551-1234, call USA. Simple but effective.
Sign your pages, use address for contact, copyright info, perhaps at the bottom.
And the secret again. Good mobile design is just good web design. Everything we've mentioned here, speed, clarity, accessibility, optimization, makes the site better for desktop users too. It's universal best practice.
Okay.
XD3, how to publish your site. Get it online.
All right, you've built your site. How do you publish it? Get it online. You need that web server. It stores your files, HTML, CSS, images, scripts. It serves them when requested.
It also keeps logs, who visited, what errors occurred, runs server-side scripts for dynamic features, and handles security, like HTTPS SSL.
Finding web hosting, maybe through schoolwork. Your ISP might offer it, or specialized web hosting companies, tons of them out there, often bundled with domain registration.
You can run your own server, but that's complex and costly. Full control, but high maintenance. Tools like XAMPP let you simulate a server locally for testing.
Organizing files for publishing, know your server's root directory, know the default file name, usually index.html or index.php, and the golden rule, case sensitivity. Most web servers, Linux UNX, treat myfile.html and myfile.html as different files.
Easiest solution. Use all lowercase for all your file names and directory names. Avoids countless file not found errors. Seriously, just do it.
Transferring files. Use FTP, File Transfer Protocol, SCP or SFTP. You'll need an FTP client program, like FileZilla, CyberDuck, Transmit.
Many code editors also have FTP SFTP built in now.
Troubleshooting publishing. Not found error. Check the URL. Check case sensitivity. Check file permissions on the server. Might need chmod.
Broken links images. Probably using local file paths, see users, instead of relative paths, images logo.png that work on the server.
Seeing HTML code instead of the rendered page. Server might have wrong MIME types configured. Contact your host at exec4v. Taking advantage of the server, PHP as an example. To unlock real power, you often need server-side applications. Why? Dynamic content, pages that change based on user input or databases. Database integration, storing and retrieving user data, products, posts.
User customization, Logins, profiles, shopping carts, and keeping sensitive logic off the client's browser calculations, business rules, secret keys.
Let's use PHP as an example. Hypertext Preprocessor. Super popular open source language. Runs on the server. PHP code lives inside .php, tags within your HTML files, or in separate .php files. Variables start with DAW, case sensitive, data types .numbers, booleans, strings, and powerful arrays, indexed or associative key value pairs.
Control structures like if-else, for loops, for each, great for arrays, while loops, standard programming stuff. Plus, tons of built-in functions.
A key use. Processing form input. PHP accesses data submitted via GET or POST through special arrays like JG and POST-A.
So when a user submits a form, your PHP script can grab that data using POOPS username, for example.
Which leads to crucial server-side form validation. You must validate data on the server even if you also do it with JavaScript on the client.
Never trust client-side input. It can be bypassed. Server validation is your security checkpoint.
And security tip. Sanitize user input before using it. Functions like HTML special cars prevent cross-site scripting, XSS by escaping HTML tags, strip tags, removes them entirely, protects against malicious code injection.
And make forms sticky if validation fails. Redisplay the form with the user's input still there, plus error messages so they don't have to retype everything. Much better UX.
PHP also has includes, include require, includients requirements, lets you pull in reusable code from other files, headers, footers, function libraries.
Keeps your code DRY. Don't repeat yourself. Once versions prevent including the same file multiple times by mistake. XXV, search engines and SEO, getting discovered.
Last section. You built it, you published it, how do people find it? Search engines and SEO, SEO, search engine optimization, making your site easy for search engines like Google to find, understand, and rank well for relevant searches. Driving quality traffic.
Google's core philosophy. Make pages for users, not primarily for search engines. Good user experience, relevant content, that's what they want to rank. What's good for users is usually good for SEO.
Key SEO best practices. Have a clear site hierarchy, logical structure. Use crawlable text links for navigation. Spiders follow links. If a page isn't linked, it might not get found.
Unique, descriptive title tags for every page. Hugely important for ranking and click-through rates.
Use relevant keywords naturally in your content. Don't stuff them in awkwardly right for humans. Keyword stuffing gets penalized.
Provide text alternatives. Alt text for images, captions, transcripts for media. Helps accessibility and SEO.
Debunking SEO myths. Cloaking, showing different content to users versus search engines. Ban, focusing obsessively on keyword density. Outdated, harmful. Paying for links, farms, penalty ban. Earn natural links with great content.
It's about quality and relevance, not tricks.
Useful SEO tools, robots.txt file tells search engines what they can and cannot crawl. Also points to your sitemap, sitemap.xml, an XML list of all your pages for search engines to easily find. Canonical links, link.rel canonical, tell search engines the preferred version if you have duplicate content. FreeG, www, vs non-www. 301 redirects permanently send users and search engines from old URLs to new ones, passing along link value.
Google Search Console, formerly Webmaster Tools. See how Google sees your site, find errors, submit sitemaps. Essential. And Google Analytics, free, powerful tool to track visitors, traffic sources, user behavior. See what's working, understand your audience. Vital for measuring success. Outro.
Wow. Okay, we covered a lot of ground there, didn't we? From the absolute basics, the core languages, HTML and CSS.
A skeleton and a style.
Yeah.
Yeah.
To getting your tool set up, building forms, adding images and video, structuring pages with semantic HTML5, making sites responsive.
Then diving into JavaScript for interaction, jQuery to simplify things, and finally, actually publishing and getting found with SEO.
It's a huge landscape, the web. Always changing, always evolving.
It really is. But those core principles we talked about, clear structure, designing for the user, accessibility, performance, those are timeless.
Definitely. So as you head out on your own web publishing journey, remember that. The most exciting websites, I think, are the ones that push the boundaries a little, the ones that embrace that spirit of discovery and creation. So the question to leave you with is, what new boundary will you stretch in the world of web publishing?